Hello and welcome back. I hope you have given it a try on your own to try to solve Grammy 13. So anyway, here is the lecture for the first way, which is this one. And this is the easiest to do because you don't need to unpack the file. So now let's get started. So the first thing we want to do is confirm whether it is packed. So to do that, we can use detect it easy. So just open the file with detect it easy. And detect it easy will show you the name of the packer and it is UPX. So this confirms that the file is packed. Sometimes, however, the certain authors may use their own customized packer which may not show up here. But in this case, it shows here, it is packed. So let's close this now. And then, before I open the file with x64, I'm going to disable the ScyllaHide first. So just select x32. And then over here, I will go to Plugins, ScyllaHide, Options, and under the profiles here, just select Disable. So it will turn off all the options. Now the reason why I'm doing this is so that you can see what happens when the debugger is not hidden. So now you can open the Grammy 13. So go to your Grammy folder and open it, Grammy 13 pack. And then now let's run it. Run it again. Okay, I have to disable my breakpoints. So let me remove my breakpoints which I set earlier. Okay, let's try again. Restart. Run. And immediately the software anti-debug feature has detected a debugger and shows up a message box telling you that the debugger is detected and the program will now quit. So if you click OK, the program is terminated, debugging stopped. So in order to defeat the anti-debug protection, and we can use just restart first, and we can use the plugin. So now we will turn on the ScyllaHide plugin, select options, and here select basic. So basic will enable all these options. Click apply, click OK. So just click OK here and close it. So now if you were to run it, immediately you will see the window showing up with the debugger status saying debugger is not detected. So now we can go ahead and find the place where the serial key is being checked. So over here we can go ahead and just key in any wrong serial key and then click the button check. So now we get a pop-up message showing us that the wrong serial key has been entered. So we can now go and pause. We are going to use the call stack method. So we are going to pause it now. And once it's alright, let's try again. Alright, sometimes you get this kind of error. No worries. If you see this kind of error, just go ahead and click OK and restart. And then run again. Just enter anything, click check, and now immediately go and hit the pause button. And this time it has paused. So now it's paused. You go and examine the call stack and look for the user module here at this address. Right click on this and click follow from. And now over here, if you scroll up, you will see that the this subroutine has been called to show this error message, and we are now coming from the call stack over here. So if you look up further, you will see a jump equal here, and this is where it is decided where to jump, whether to jump or not to jump. So basically we want it to jump. If we don't jump, it will show the wrong serial key message, and this is the bad message, so we want it to jump. So this is where we should patch to make it jump. So before we patch, take a note, this is the address and this is the place to patch. So we actually can't patch a pack file, so we have to unpack it first. So in this case, we don't want to unpack it. So what we do is we need to use a loader to pack the process, not the file. So in order to pack the process, first you must find out the what bytes that you want to patch. So to do that, you double click to assemble, although you really can't assemble it in the file itself, but you can now assemble it just to check whether it works. So we are going to jump to this address, so we assemble jump, make sure the address is the same size or smaller, and then OK, and close it. So now if it comes here, it will jump. So we can put a breakpoint here, and then now do not restart. If you restart, you will lose all this because the file is packed, and whatever is packed and you put a breakpoint, you will lose the breakpoint. So do not restart. Just go to the program itself here and click OK. Click run first. Just click run first, and then go here and click OK, and then click check again one more time, and now you see it has hit our breakpoint, and you can tell that it is going to jump because we just assembled the jump here. Alright, so now we are not going to patch this, but we want to get the offset address, so we click file. Although we are clicking patch file, we are not actually going to patch it. We are just going to export this offset address. So over here, you export it and call it patch offset. If you forget how to do loaders, you can go ahead and revise the lessons on loaders earlier. So now we save the patch offset, and then one file exported. So now we just skip the patching because you won't be able to patch a pack file anyway, so just skip this. So now just close, and we can now go and do our loader. So now we go to open our dUP2 over here. If you don't know how to get dUP2, just refer back and revise your lesson on loaders. So double click dUP2, create a new project, click on project new, and give a name here, CrackMe13, and here select the file, go to your CrackMe, select the file itself, and then over here just leave everything as it is, click save, and then select this and right click, add offset patch. So click offset patch, and now over here right click, edit. You can either select edit or you can just double click on it. So now your target file, just select it again, which is this file. Over here you select relative virtual address, and then over here go and open your exported patch offset file by using Notepad, and then the address. This is the offset address. So select the offset address, paste it in the offset, make sure you're using RVA, and then the original byte is 74, and you want to patch it to become EB. Alright, so now you've done that, click add. And if you had any more other bytes to patch, you just keep adding them here in the list. So that's all for this part, so we just save now. And now we can save our project. You can leave the default name with dUP2 extension. Now we can create a loader. So select project, create loader, select simple loader, click OK. And then the default name is fine, just save it. So you can run it now, or you can run it manually. I will run it manually, so I click no and go here and run the loader. So this is a new file, a new loader has been created. So just double click it, and now you can enter any key, click check, and your loader has successfully patched the running process in the memory. Note that we are not patching the file here, we are patching the process which is running in memory. You can actually see the process by using Task Manager. Click here, Task Manager, and then when the Task Manager open, select more details, and you can see here CrackMe is 13 is running in memory. So you are patching the memory itself, not the file. Why do I have 2 here? Because my x64 DBJ is open, so I just close this, and you will see there should be 1 only. So this is the one which is for patching the process in memory itself, not the file. Okay, so that's how this thing works using loaders, and I'll see you in the next one. Thank you for watching.